Alright guys, so I just got home. I'm ready to work on a video for you guys. This is the latest print I'm working on. It's on the printer right now. And it's just another part of the SpaceX spaceship that I'm building. Alright, so a lot of you have been asking me on what the K values are, and it made a huge difference. I just want to show you guys what I mean by a huge difference. As you can see, this is one of my other prints. Now I'm using a 0.8 millimeter nozzle, so the difference that you guys see here, the issues that you see are exaggerated just because of the size of the nozzle. Let me just show you the seam on the inside. That looks terrible. And some of that failed. Alright. This is a little bit better. See, look at that. Look at how good that looks. But we get to some of those letters and look at what starts happening. Look at the seam right here. I tried hiding it right in that corner, but that was terrible. I'll show you the inside. Alright. Here's another one. This is really good too. All in all. But then you have something like this. Look at the detail. It looks so good. But there are some just silly mistakes. Look at the seam right there. Still looks really good. I was really happy with this print. But then those little mistakes got me to ask on the Snapmaker's group. And look at that. This is after doing my K values. Alright, look at the seam. Look at that seam. Just wow, look at that. I'll show you the inside. Let me show you the seam on the inside. There's a tiny little mistake. It even looks worse on camera than it does in real life. So, alright. So I'm gonna get into calibrating not just your K values, but also your E steps. Alright guys, so let's get right into it. First thing you're going to do is you're going to click on the link in the description below. That's going to take you to this website by Teaching Tech. This is a GitHub website and it's open sourced. It's an amazing tool for 3D printer enthusiasts. And really what you're going to be prompted is you're going to get to this website and you're probably going to come into either home over here or you're going to get to calibration. Okay, so you're going to click on calibration. It's going to take you to introduction, and if you want to work on through all the calibration steps, he's got a great video on everything that you can calibrate. I'm gonna focus on the things that are the most important things, I think, when it comes to quality. I'm sure you guys have heard of temperature calibration, your retraction calibration, and all those other things, but that's not what this video is going to be about. This is going to be about the E steps and the linear advance feature in Marlin. That is the firmware that our printer uses. Okay, So if you are in the introduction tab, just click over to the Extruder E-step calibration. And now let's go over to Luban. We are going to open the workspace. And you have to connect to your printer using this serial port. You have to find the actual cable and connect directly your computer to your printer. First thing we're going to do is we're going to send an M92 command. We're going to connect to the Snapmaker, and good luck doing this. Took me a few tries, but I was finally able to connect. I'm choosing my A250 because that's the machine I have. The M92 command is going to give us the settings that the machine has saved. In my case, it's E228.51, 228.51. And after that, we are going to follow that with the command G91. Command G91, it's just going to place the printer into relative movement so that what we are going to do next is accurate. Then we warm up our machine. I'm setting it to 215 degrees, and I'm just going to wait for the temperature to get there. And I'm using the touchscreen to warm up the nozzle. While the temperature gets there, I am measuring using a caliper 120 millimeters from the top of the tool head, as you can see there. And then we're going to send this command. It's going to be G1E100F50. And that's just basically telling the printer that we are going to extrude 100 millimeters. Alright, and there goes 100 millimeters. And it's gonna go a lot slower than you can see it in the video. You just gotta wait for the 100 millimeters to be extruded. It always makes some fun shapes. And you should have 20 millimeters left. Alright, now we go back to the website. We're going to use the calculator. We're going to enter our previous E-steps, which is what we got before, back when we enter the M92 command, and mine was E228.50. And now we're going to measure whatever amount was left from the top of the tool head. In my case, it was around 24.29, and I'm sure that your case was also different. So just enter whatever amount you had there. Then we're just going to hit calculate. That's going to give us what we need, all right? And that's just my old value, and that's just telling me how many millimeters I extruded instead of the 100 that we wanted to. That is going to be our command, so it's M92 E238.75, which is our new E-steps value, and we're gonna follow that with an M500 so we can save everything to the printer. Alright, so M92 E238.75. Now remember, that is for my printer. Your value is going to be different. Hit OK, and now enter our M500 command. She's telling us that our settings have been stored. Now we're going to do this all over again. The reason we're going to do this all over again is because now we want to make sure that we are in fact extruding 100 millimeters. And when you're done getting your each steps correct, then the next thing you got to do is set your printer back to absolute position by sending a G90 command. It will still be done if you were to power cycle a printer, but just to be safe, just send a quick G90 command to your printer. Alright, now we're on to the linear advance, and this is what most of you have been waiting for. I don't want to get into details on what linear advance is doing, but just know that this is a parameter that the Snapmaker from factory is not correct. It's really far off, and it makes a huge difference when you calibrate this parameter. So this is what we're going to do. We are going to be scrolling down on the website. Just click on this link right here. I'll make sure to add this as a link in the description below. I'll call it linear advanced pattern. And then when we click on this link, it's going to it'll take you straight to the pattern generator. I'm gonna name my printer in a second, but these are all the parameters. We're not gonna change all of them. We're just gonna touch a few of them. This is what I call my printer. Call it Snappy. Alright, I'm gonna set my nozzle temperature to 200. It's what I usually use with this filament. Yours might be different. I'm going to set the layer height to 0.3. That's just to make it a little more visible for me. Here's where you're going to set your bed shape. So yours might be different if you have an A350. These are the speeds at which the printer is going to be moving at. We're not going to touch any of those. I am going to change my retraction speed because that's what I have, and I know it works with what I have. But it's up to you. You can just leave yours that. And the rest of the settings I'm just going to leave like that. I'm going to name the file linear advance test. You can call it whatever you want. Just gonna hit generate code and download file, and then head back to Luban. We're gonna open the G code that we just created. We're gonna connect to our printer. And now we're gonna send the G code via Wi-Fi to the printer. Alright, and this is the result of the first print. It literally took like 30 seconds printing. Okay, so what we're looking for here is for a line like the one in the bottom. Something that looks very even, nothing like the ones on the top. But that one's still not right. So now I'm going to fine tune. Going back, I'm going to change the default. I'm going to put it a little bit finer. I'm going to have the ending value to 1. And now the K factor stepping, it's going to be 0.05. Hopefully by now you're understanding what's going on and how the pattern is being printed. It's basically just going through different motions and it's writing down the value right next to the line. So that's what you're looking for. Now I'm changing the name to Linear Advanced Test 2, going back to Luban, open the new G code in Luban, and sending it over to the printer via Wi-Fi and printing it again. Alright, here's the results for the second test. And then we're going to see the results for the third test. I figured out that my K value is 0.025. Now yours might be different again. Alright, so we're going to send an M900 command, and that's going to give us what your K value currently is. As you can see here, mine is already changed. So it's 0.03, but yours is going to definitely be different. Now I'm sending my new value, right? So it's going to be M900 K and whatever your new value is. In my case it was 0.025. I'm sending it, And now I'm following it with an M500 command, and this is just saving all the settings to the printer. Alright, if I run an M900, it's just going to give me my results. So there you go, guys. That is how to calibrate your Linear Advance, and I really hope this helps as much as it helped me. I'm planning on making a few more videos in the future. I'll cover some more calibration steps and so many other things with the Snapmaker. If you are interested and if you like the video, consider following so that you are notified next time I make a new video about this.